composition of two SHMs having same period and along the same path. Where composition of two SHMs, two displacements, a particle can be subjected to two SHMs having different amplitudes. Consider two SHMs having different amplitudes and their initial phases are different. Therefore, x1, x2, the resultant displacement can be calculated by using x is equal to x1 plus x2. The resultant displacement of the two particles or two SHMs, the resultant displacement x is equal to x1 plus x2. According to superposition principle, x is equal to x1 plus x2. Initial wave, suppose first wave gives a displacement and second wave having amplitude, that amplitude is a1, and second wave its amplitude is again a2. Therefore, the resultant displacement of that two waves, the resultant displacement, according to the superposition principle, the resultant displacement obtained is the vector sum of that two individually present. Therefore, x is equal to x1 plus x2. Therefore, x1 plus x2, substituting that value and by using relation x is equal to x1 is equal to a1 sine of omega t plus phi 1 plus a2 sine of omega t plus phi 1. By using an trigonometric identity, sine of a plus b, sine of a plus b is equal to sine a cos b plus cos a sine. Using that relation and solve the equation to calculate the resultant displacement. Therefore, x is equal to a1 and that term can be expanded by using that formula sine of omega t cos phi 1 plus cos omega t sine phi 1 plus a2 in bracket, again expansion of sine omega t plus phi 2 term, a2 in bracket sine omega t cos phi 2 plus cos omega t sin phi 2, multiplying a1 term throughout and collecting the term because of sin omega t is the constant term, a1 cos phi 1 plus here cos phi term, sin omega term should be calculated and collected that term sin omega t terms, a1 sin omega t cos phi 1 multiplied by sin omega t, expansion of that equation, and a1 cos omega t sin phi 1 plus a2 sin of omega t cos phi 2 plus a2 cos omega t sin phi 2, where sin omega t terms are collected and cos omega t terms are collected. Therefore, we get the equation resultant displacement x is equal to a1 cos phi 1 plus A2 cos phi 2 multiply by sin omega t plus cos omega t terms are connected. Therefore, A1 cos omega A1 sin phi 1 plus A2 sin phi 2, and the common term is cos omega t. Therefore, the terms can be calculated. X is equal to cos 1, cos terms are separated and sin terms are separated. Therefore, x is equal to, that equation can be written where A1 cos phi 1 plus A2 cos phi 2 is equal to, using that equation, A1 cos phi 1 plus A2 cos phi 2 is equal to R cos delta. Cosine functions here. Therefore, the term can be calculated. R is used as resultant amplitude. R can be calculated. R is denoted as resultant amplitude of the two SHMs. Therefore, R can be taken, and when delta is the phase difference in between the two waves. Therefore, that term can be calculated. A1 cos phi 1 plus A2 cos phi 2 is equal to R cos delta. And another equation, A1 sin phi 1 plus A2 sin phi 2 is equal to R sin delta. Therefore, that equation can be written as x is equal to R cos delta sin omega t plus R sin delta cos omega t. Therefore, that equation can be written as in that form. Here, sin omega t cos delta and cos omega t sin delta. Again, by using that identity, sin of equation sin with that trigonometric equation, sin of a plus b is equal to sin a cos b plus cos a sin b. Hence, x is equal to R sin omega t cos delta plus cos omega t sin delta. Arrange the terms. We get the equation x is equal to R sin a plus b. Therefore, sin of a is omega t and b is delta. Therefore, the resultant amplitude is taken as R, and the resultant displacement of the two SHMs, x is equal to capital R sin of omega t plus delta, where delta is capital R is equal to resultant amplitude of two SHMs. Resultant amplitude, and delta is the phase difference. Delta phase angle. Delta is the phase angle, and capital R is denoted as resultant amplitude. By using that equations, equation number 1 and equation number 2, that equations can be used and calculate the value of resultant amplitude. Calculate the value of resultant amplitude. R can be calculated by using that